Okay, so this problem is going to be from the elevator dynamics homework number 1. This is problem number 5. And really quick, I'm just going to be going through and selecting information out of the problem. So an elevator has a mass of 1,400 kilograms. What is the tension in the supporting cable when the elevator is traveling downwards at 10 meters per second? It is brought to rest in a distance of 40 meters, and acceleration is constant. So to do this, I'm first going to start by listing out what we were given. So the mass of 1,400, the initial velocity of -10, the final velocity of 0, and the displacement of 40. So because we are looking at forces, I'm kind of going to draw a free body diagram for this little elevator right here. So we have a tension pointing upwards and a force due to gravity pointing downwards. So we could set up Newton's second law, sigma F is equal to ma. Our forces are going to be tension minus F of g is equal to ma, and we need to solve for an acceleration in order to find our tension. And because we were given all of the information like velocities and displacements, we know to use common form. So common form is going to be Vf squared minus Vi squared is equal to 2a times your displacement. Our final velocity is 0 squared minus -10 squared is equal to 2a times 40. This can ultimately be rewritten as -100 is equal to 80 times a, and this will give us an acceleration of -1.25 meters per second squared. And then we can go back to our force equation. So we have tension minus mg is equal to ma. And then we could plug in our numbers. Tension minus, we have 1,400 times 9.8 is equal to 1,400 times -1.25. So we have our tension is going to be minus 13720 is equal to -1750. That's a 7, not a 2. And then when we move that over, we get our tension to be 11970. And this is actually incorrect. If we look back at my common form equation, I feel like this is a better way to show why this is incorrect. We have a negative acceleration, and this just doesn't make sense for this type of problem. So because our elevator was initially moving downwards, our velocity is negative because velocity follows the line of motion, and the elevator is slowing down. And if we look back at our justifications, for an object to be slowing down, velocity and acceleration have to have opposite signs. So our acceleration must be positive. And now I'm going to be redoing the math to show you how to solve for a positive acceleration, rather than making the same mistake I did. So we have common form, which is Vf squared minus Vi squared is equal to 2a times your displacement. I'm rewriting displacement as the change in x, so xf minus xi. I feel like this makes it simpler. So Vf is 0 squared minus -10 squared is equal to 2a. And our final position is actually going to be at 0, and our initial position is going to be at 40. If we think about the elevator motion almost like a y-axis of a graph, we see that 40 is at the top and 0 is at the bottom. So it travels a distance of 40 with its final position being at 0. So we have -100 is equal to -80a. So our a is going to come out to be a positive 1.25. And then we could just follow the rest exactly the same. So t minus fg is equal to ma. And our mg is going to be the same. So that number does not change. And the number on the right is just the absolute value of what we had gotten previously. So we now get a tension to be this value.